On February 28, 2026, the United States, Israel, and Iran engaged in Operation Epic Fury. The strikes were characterized by incredible volume and speed, directed not by human generals, but by algorithms. For most of modern history, battles were fought by maneuvering thousands of infantry troops across physical terrain. Today, conflict is waged through data-centric networks, where sensor grids and processing power dictate the outcome. This visualization compares troop deployments across two eras. During the 1967 Six-Day War, over 700,000 soldiers were mobilized. In 2026, the theater saw fewer than 50,000 ground troops. Those human armies are being replaced by two technological pillars. First is precise mass, deploying overwhelming volumes of cheap, accurate hardware. Second is algorithmic targeting, using software to identify and sort targets at machine speed. Look at this photo. During World War II, analyzing reconnaissance maps and planning a single strike required rooms of human analysts working under low light for weeks or even months. In the massive human-centric theaters of the two world wars, armies engaged each other across heavily populated, clearly defined front lines. This chart tracks the percentage of civilian casualties in major global conflicts from 1900 to 1945. At the turn of the 20th century, civilian fatalities sat at 5%. By the end of the First World War, it was 15%, and by the end of the Second, it reached roughly 65%. But extending this data into the modern era of asymmetric warfare reveals a massive surge. Since the 1990s, the civilian casualty rate has risen to over 90%. By the early 2000s, aircraft like the Predator drone, seen here in flight, began bridging that gap. They beamed live video directly to operators, compressing the targeting timeline down to hours or minutes. Today, the machine processes the data, makes the connections, and generates the target. The software operates so fast it eclipses human cognition entirely, stripping meaningful human judgment out of the battlefield. This brings us to the first broken equation of modern combat, algorithmic asymmetry. Software is now generating lethal targets much faster than any human can actually verify them. This graph illustrates exactly how it works. Systems used by the Israeli military, like Lavender and the Gospel, ingest massive datasets, phone records, social media networks, and satellite imagery. The algorithm maps a single known militant, seen here in the center, and mathematically assigns suspicion scores to dozens of unknown people based purely on shared behavioral patterns. Once a person is flagged, companion tracking programs monitor their mobile phone. The system waits until the target enters a specific location, usually their family home, and then triggers an immediate aerial strike alert. To understand the sheer volume, consider that human analysts working manually used to generate around 50 targets in an entire year. These AI systems can generate 100 targets in a single day. The United States military relies on similar integrations. Programs like Project Maven depend heavily on commercial big tech contractors to process huge streams of battlefield data and suggest strikes. When the speed of war accelerates to this extreme, human operators fall victim to automation bias. This is a psychological failure where people blindly trust a machine's output without verifying the underlying data. The operator simply becomes a rubber stamp for lethal action. That leads us to the second broken equation, economic asymmetry. The cost to launch an attack has become radically cheaper than the cost to defend against it. Look at the basic delta wing profile of this Iranian Shahed 136 drone in flight. It is intentionally slow, built with simple commercial parts, and costs only about $30,000 to manufacture. Because they are so cheap, the offensive strategy is saturation. Militaries launch massive swarms of these explosive drones simultaneously, flying them low across the landscape to completely overwhelm advanced radar networks. The financial burden this places on the defender is massive. To shoot down a swarm, the United States and its allies have to fire interceptors from highly complex systems like the Patriot battery seen here, or THAAD, both of which are advanced, highly sophisticated air defense missile networks. This chart illustrates the extreme financial mismatch on the battlefield. A single Shahed drone costs around $30,000 to build. A single US Patriot interceptor missile costs roughly $4 million to fire. Multiply that by hundreds of incoming drones, and the math heavily favors the attacker. For every dollar spent launching a drone, the defending nation has to spend over $100 to shoot it down. No military budget on Earth can afford to continuously outspend a drone swarm at that rate. The traditional financial framework of national defense is mathematically obsolete. The physical aftermath of these broken equations is catastrophic, but in a war of attrition, those expensive platforms become financial liabilities. In the physical domain, the advantage belongs to whoever can manufacture the highest volume of accurate weapons for the lowest price, slowly bleeding the enemy's treasury dry. To counter the sheer volume of these attacks, the US and Israel turned to software. They deployed artificial intelligence to accelerate their own targeting capabilities. In military operations, the kill chain is the process of gathering intelligence, identifying a specific threat, and executing a lethal strike against it. Historically, human cognition has been the bottleneck in this chain. Looking at this graph, we can see the acceleration of this process. A team of human analysts might identify 50 targets in a year. Proprietary AI systems like Israel's The Gospel and Lavender can generate over 100 targets in a single day. These algorithms achieve this speed by ingesting massive datasets. They scrape intercepted cell phone locations, social media connections, and satellite feeds, instantly grouping abstract data points into actionable target lists. As seen in the vast scale of structural destruction in this residential neighborhood, the ongoing conflicts in Gaza and Iran have resulted in staggering, massive death tolls. Because AI targeting relies on sheer volume to be effective, militaries have reportedly programmed their systems to tolerate extreme collateral damage. In some cases, commanders have accepted up to 100 civilian deaths just to eliminate a single flagged target. The internal language used to describe this process is deeply dehumanizing. Lower-level individuals generated by the algorithms are officially referred to within the military apparatus as garbage targets. The commercial technology sector is heavily implicated in this reality. Major cloud providers and AI developers have directly embedded their data centers and machine learning infrastructure into these military command structures. Software engineers are discovering that their civilian cloud servers and data architecture are actively powering lethal military operations overseas. To survive incoming swarms, militaries are adopting the Ukraine model. Instead of million-dollar missiles, defenders launch highly agile, mass-produced interceptor drones. Militaries are trying to fix the economic asymmetry. They are testing cheaper defensive alternatives. The long-term technical solution lies in directed energy weapons, or lasers. These systems offer an infinite magazine capacity, burning through incoming drones at the cost of pennies per shot. But the technological arms race continues to outpace any ethical guidelines. Notice the rows of empty seats at the UN General Assembly. Despite the mass casualties and rapidly shifting military tactics, the international community has completely failed to establish binding treaties regarding autonomous lethal AI. As long as international law remains silent and this technology continues to scale, the ultimate decision of who lives and who dies has permanently shifted from human morality to machine efficiency.